What if I told you the biggest reason Toyota hybrids get such incredible fuel economy isn't the battery at all? In fact, the real secret is hiding under the hood in an engine design that most drivers have never heard of. Toyota intentionally built an engine that sacrifices power to gain something far more valuable: efficiency. And that single engineering decision helps explain why vehicles like the Prius, Camry Hybrid, Corolla Hybrid, and RAV4 Hybrid consistently deliver fuel economy numbers that many competitors struggle to match. But how does this unusual engine actually work? Why don't more automakers use it? And what are the trade-offs Toyota had to make to achieve such impressive results? In this video, we're breaking down Toyota's hidden engine technology, how the Atkinson cycle works, why it pairs so perfectly with hybrid systems, and the real reason it has become one of Toyota's biggest advantages. The secret behind Toyota's hybrid efficiency isn't about creating the most power possible. Instead, it's about getting more useful energy out of every drop of fuel. In a typical gasoline engine, a significant amount of energy escapes through the exhaust as wasted heat. Toyota's hybrid engines are designed to reduce those losses and improve overall efficiency. The downside is that this approach naturally produces less low-speed torque than a conventional engine. That's where the electric motor comes in. Because electric motors deliver instant torque, they compensate for the engine's lower output during acceleration and low-speed driving. This allows the gasoline engine to focus on operating in its most efficient range, while the electric motor handles the extra workload when needed. What's even more interesting is that Toyota doesn't rely on a traditional Atkinson cycle engine design. Instead, it uses advanced variable valve timing technology to create a similar effect inside a modern engine. So how exactly does Toyota make this system work? In a conventional gasoline engine, the intake valves close shortly after the air-fuel mixture enters the cylinder. Toyota takes a different approach. The intake valves remain open slightly longer as the piston begins moving upward. This allows a portion of the air-fuel mixture to flow back into the intake manifold before the compression stroke fully begins. The result is an engine that compresses less of the mixture it originally pulled in, because less energy is spent on compression, while the full power-producing expansion stroke is retained. Overall thermal efficiency improves. In simple terms, more of the fuel's energy is converted into useful work instead of being wasted. This strategy, known as late intake valve closing, allows Toyota to mimic the Atkinson cycle while using a conventional engine architecture. What's even smarter is that the system can constantly adapt. During highway cruising and light load driving, Toyota maximizes the Atkinson effect to improve fuel economy. When stronger acceleration is needed, valve timing can be adjusted to deliver better performance and responsiveness. Of course, this efficiency-focused design naturally reduces low-end torque, but that's where the hybrid system comes into play. The electric motor instantly provides the torque the engine gives up, creating the smooth blend of efficiency, performance, and drivability that has become a hallmark of Toyota hybrids. At first glance, an Atkinson cycle engine might seem like a compromise. Because it compresses less air than a traditional engine, it naturally produces less power on its own. In most vehicles, that would be considered a disadvantage. But Toyota turns that limitation into one of its biggest strengths. By reducing the work required during the compression process, the engine wastes less energy internally. Traditional gasoline engines lose a portion of their fuel energy simply moving air through the engine and compressing it. Toyota's approach minimizes those losses, allowing more of the fuel's energy to be used for actual propulsion. Another advantage is lower combustion temperatures and pressures. This means less energy escapes as heat through the cooling system and exhaust, improving overall efficiency. Put simply, more of every gallon of fuel goes toward moving the vehicle rather than being lost to waste. But the real magic happens when this engine is paired with Toyota's hybrid technology. During low-speed driving, traffic, and stop-and-go conditions, the electric motor can handle much of the workload. This allows the gasoline engine to operate only when it can do so efficiently, or shut down entirely when it isn't needed. Instead of constantly responding to every throttle input, the hybrid system keeps the engine operating closer to its most efficient range. That's one of the main reasons Toyota hybrids excel in city driving, where conventional gasoline engines are often at their least efficient. On paper, the Atkinson cycle sounds like the perfect solution. But as with any engineering design, there are still trade-offs Toyota had to overcome. Up to this point, the Atkinson-style approach sounds almost too good to be true. It improves fuel efficiency, reduces wasted energy, and helps Toyota hybrids achieve impressive fuel economy. But every engineering solution comes with a compromise. The biggest drawback is reduced torque output. Because part of the air-fuel mixture is allowed to flow back out before compression is completed, the engine produces less low-speed pulling power than a conventional gasoline engine of similar size. In a traditional vehicle, that could lead to sluggish acceleration and a less responsive driving experience. For many drivers, that would be a deal-breaker. But Toyota approached the problem differently. Instead of redesigning the engine to recover that lost torque, they paired it with an electric motor. This is where the hybrid system shines. Electric motors generate maximum torque almost instantly from a standstill. While the gasoline engine focuses on operating efficiently, the electric motor provides the immediate response needed during takeoff and low-speed acceleration. The result is a system where both components complement each other perfectly. The engine delivers excellent efficiency, while the electric motor fills in the performance gaps. Together, they create a driving experience that feels smooth, responsive, and effortless in everyday conditions. This balance is one of the main reasons Toyota hybrids have been so successful. Drivers get the fuel-saving benefits of an efficiency-focused engine without sacrificing the responsiveness they expect from a modern vehicle. If you're enjoying the video so far, don't forget to like, subscribe, and turn on notifications for more Toyota hybrid insights and ownership tips. So if Toyota solved the biggest weakness of the Atkinson cycle years ago, why does it remain such an important part of Toyota's latest hybrid systems? The answer reveals a lot about the future of hybrid technology. You might think that with modern turbocharged engines, advanced hybrids, and the rise of electric vehicles, Toyota would have abandoned the Atkinson cycle long ago. But the reality is quite the opposite. Toyota continues to use it because it remains one of the most efficient gasoline engine strategies ever developed. Over decades of refinement, Toyota has combined Atkinson-style operation with advanced fuel management, precise valve control, and sophisticated hybrid technology to maximize efficiency while maintaining excellent reliability. There's another benefit many drivers never consider: longevity. Because the engine often operates under lighter loads and spends more time in its most efficient range, internal stress is reduced. That's one reason so many Toyota hybrids are known for lasting hundreds of thousands of miles with proper maintenance, and that's Toyota's real engine secret. While batteries and electric motors get most of the attention, the foundation of Toyota's hybrid success starts with an engine design focused on efficiency first. If you enjoyed this video, don't forget to like, subscribe, and turn on notifications.